In this lesson, we are going to be graphing a quadratic on the coordinate plane using intercept form. Take a look at some examples of quadratics that we see in our world today. Here's an arch, golden arches, even a satellite dish. So the first thing that we want to take a look at is some vocabulary for graphing and for using with parabolas. So remember that a parabola is the graph of a quadratic function. Intercept form for the equation of a quadratic is y equals a, where a is our leading coefficient, x minus p, x minus q, where p and q are our x-intercepts. P and q are our x-intercepts. Here are some properties of the parabola. If a, the leading coefficient, is greater than 0, then our parabola opens up. If a, the leading coefficient, is less than 0, then our parabola opens down. If the absolute value of a is greater than 1, then our parabola becomes narrower. If a, our absolute value, is less than 1, meaning a fraction or decimal, our parabola becomes wider. Remember that the vertex is the lowest or highest point of the parabola. At the lowest point, it would be called the minimum, and that is when the parabola is opening up. And at the highest point, when our parabola is opening down, then the vertex is a maximum. The axis of symmetry is the vertical line that divides the parabola in half. Remember that each side matches, so the parabola reflects from one side to the other. Let's begin by graphing a parabola. So the first thing we want to do is to determine by looking at the leading coefficient if our parabola opens up or down. Our parabola has a positive leading coefficient, so it's going to open up. Our x-intercepts are found by taking the factors and setting them equal to 0 and solving. So if I have x minus 3 equals 0, and I add 3 to both sides, we find that x is equal to 3. So our first x-intercept will be at the point 3, 0, remembering that when you cross the x-axis, that y is 0. Our second, if we set this equal to 0 and solve, we subtract 1 from both sides, so we have x being equal to negative 1, and that's our second x-intercept. Remember, to find the axis of symmetry, we're going to add the two x-intercepts together and divide by 2. So 3 plus a negative 1 is equal to 2, and 2 divided by 2 is equal to 1. So our axis of symmetry is an equation of a vertical line where x is equal to 1. Remember that the vertex passes, the axis of symmetry passes directly through the vertex, so the x portion of our vertex is the axis of symmetry. So in order to find the y part of the point, we're simply going to substitute the 1 into our equation and solve for y to find the y part of our vertex. So we have y then is equal to 2 times 1 minus 3, which is negative 2, times 1 plus 1, which is 2. And when we multiply those together, 2 times negative 2 is negative 4, times 2 is negative 8. So we have 3 points so far. We have our vertex, which is at 1, negative 8. And then we have our intercepts on either side of that. So we have our intercepts at 3, 0 and at negative 1, 0. So what we'd like to do next is to find a point on either side. So let's first of all graph those 3 points. We have 1, negative 8. We have 3, 0. And we have negative 1, 0. So let's find a point on the other side at 4. So we're going to put 4 into our table, and we're going to substitute it in and find out what the y value is if our x value is at 4. So when we work that out, we have y then is equal to 2 times 4 minus 3 is 1 times 4 plus 1 is 5. So that's going to give us a value of 10. So we have 410. And if we draw in our axis of symmetry using a dotted line, that will tell us what our midline is, where we can divide our parabola in half, and we can reflect this point 410 without calculating to the other side of the parabola. So this goes 3 units to the right. We are now going to go 3 units to the left, and that's going to be at the point -2, 10. And then we can go ahead and graph our parabola. Okay, so we start down here, and we are going to draw our parabola with the smoothest line as possible, going up on either side. And if we take a look, whoops, I got off a little bit on that one. If we take a look, we can see our parabola is going up. And if we take a look at the leading coefficient, which is +2, we can see that our parabola is a little bit narrower since it has an absolute value that is greater than 1. Let's take a look at our next example. We have x squared plus 6x equals 7. So the first thing we need to do is to subtract 7 from both sides. So we have x squared plus 6x minus 7 is equal to y. We want to find our intercepts by factoring. So what two numbers can I multiply together that give me -7, but when I add them I get +6, and that's going to be +7 and -1. So what we do is we set these equal to 0 and solve, which means we're basically taking the opposite of what we see in the parentheses. So that's going to give us x-intercepts at -7, 0, and +1, 0. Taking a look at our leading coefficient, it is 1, not written, but we understand it to be there, and since it's a +1, we know that our parabola is opening up. Axis of symmetry. We're going to add these two together, so -7 plus 1 is -6, and we're going to divide by 2, and that's going to tell us then that our axis of symmetry is at -3. And because the axis of symmetry passes directly through the vertex, we know that the x value of our vertex is at -3, and now we want to find the y value. So we know that y equals -3 plus 7 and -3 minus 1. So y then is equal to +4 and -4, which means that's going to be at -16. So our vertex is at -3, -16, and we have our x-intercepts at -7, 0, and at 1, 0. So because we have our vertex being at -16 for our y value, we're going to want to go by 2's when we graph these points. So we're going to go -3, which means 1.5 boxes, and then down 8 boxes, which would give us -16. Then we're at -7, 0, which is 3.5 boxes, and at +1, which is going to be a half of a box, 0. So let's take a look if we're at +2 to find that point. So y is equal to 2 plus 7 and 2 minus 1 when we substitute in to find the other part of our point. So that's going to be 2 plus 7 is 9, and 2 minus 1 is 1, and 1 times 9 would be 9. So that's going to be at the point 2, which since we're going by 2's, that'll be 1 box, and then up 4.5 boxes to 9. So what we could do then, make sure we draw in our axis of symmetry, and you can make that dotted line to show where our parabola is going to divide in half. And then we can reflect this point over to the other side. So we have 1, 2 and a half boxes. So we have half, 1, 2 boxes. So that's going to be at the point -8, +9. And then we will draw in our parabola, making sure to put arrows on both ends so that we show that it continues infinitely. Let's take a look at another example. We have y equals 2x and then x minus 4. Taking a look at our leading coefficient, it's a +2, so we know this is going to open up. So we're going to set these equal to 0 to finish solving. So we have 2x equal to 0, so x is equal to 0. And then we have x minus 4 equal to 0, and when I add 4 to both sides, I'll have x being a +4. So our x-intercepts are going to be at the origin, which is 0, 0, and at +4, 0. So to find our axis of symmetry, remember we're going to add the two together. 0 plus 4 is 4. And then divide by 2. So our axis of symmetry will be at a +2. Our vertex has an x-coordinate of 2 since the axis of symmetry passes through that. And then we're just going to substitute in to find our y value. So y equals 2 times 2. And then 2 minus 4. So that's going to be at 2, 4, and then -2 would give us a -16. I think I have too many 2's there. Nope, 2 times 2 is 4. I have an extra 2 right here is where I have my extra 2. And that will be then at -8. Alright. So our vertex is at 2, -8. Vertex at 2, -8, and then x-intercepts at 0, 0, and 4, 0. So we're at 2, -8, if you want to graph that, and at 0, 0, and at 4, 0. So let's find out what would happen at x being 5, which is right to the right of that intercept. So we have y equals 2 times 5, and then 5 minus 4. So that's going to give me 10 times 1, which is 10. So we're going to be at the point 2, 10. Or excuse me, 5, 10. So we'll mark that in at 5, 10. We will make sure we have our axis of symmetry. And since we went 3 to the right from the axis of symmetry, we're going to go 3 units to the left, and that's going to be at -1, +10. And then we can draw in our parabola, making sure to put arrows on both ends to show that it continues infinitely in that direction. Let's take a look at our last example. So we have y equals -x minus 2 and x minus 2. Taking a look at the leading coefficient of -1, this time since it's negative, we know our parabola is going to open down. Now we have x minus 2 and x minus 2, so if I set these equal to 0 and solve by adding 2 to both sides, we get the same exact answer. So that means that we have only one x-intercept this time, which is at 2, 0. Now our axis of symmetry is the line that divides the parabola in half. So what we're supposed to do is to take our x-intercepts, add them together, and divide by 2. Well, they're the same point, so 2 plus 2 is 4 divided by 2 is 2. So our axis of symmetry goes through the point 2, 0 at 2. And we also will find out if I put a 2 back into the equation, 2 minus 2 is 0. So in this case, our x-intercept and our vertex are the exact same point at 2, 0. So let's do a point on either side after drawing in our axis of symmetry. Let's start by using the point 3. So if I plug 3 in, I have y equals negative 1 times 3 minus 2 times 3 minus 2. 3 minus 2 is 1, so we have 1 times negative 1. That's going to give me negative 1. So we're going to be at 3 negative 1, and I'm going to reflect that point directly to the other side, which is going to be at 1 negative 1. Now let's try 4 for our x value. So we have y equals negative 1 times 4 minus 2 and 4 minus 2 substituting in. So we have negative 1 times 2, which will be at negative 4. So we're going to be at the point 4, negative 4. And we will reflect that to the other side, which means that that's going to be at 0, negative 4. Make sure that you're filling in your table, please. And now draw on your parabola. Whoops, not quite as wide. Okay, now let's review. The first thing you want to do when you're graphing your parabola is to make sure to find the x-intercepts using your intercept form. Then we add the two together and divide by 2 to find the vertex, and then make sure you pick other points to complete the table. But remember, if you find one point, you can reflect it to the other side without having to do any calculations. Does the parabola open up or down? The decision to make when looking at the leading coefficient. And then remember, when you're finding the axis of symmetry, you're taking the x-intercepts, adding them together, and divide by 2. Please remember to complete the reflection.